Hi everyone, welcome to Python Osmosis episode 46, the screencast that helps you get your non-sequentially dependent jobs done more quickly. I'm Ryan Shea, and in this episode we'll be talking about the standard library, multi-threading. A lot of people want to know about multi-threading. For things that can run at the same time, you can put them into threads. Most programs, they run sequentially, first line, second line, third line, but threading provides you a way of taking some of those things that just sort of lag and running them in the background. If nothing after it is dependent on it, why not? So let's import threading, and we're also going to import zip file. We're going to make an asynchronous zipper. So the way that you do threading, or at least a good high-level way of doing it, is using the threading module that we just imported. And what you do is you create a new class, a subclass of threading.thread. And there's two things you do. You override init and you override the run methods of this class. So let's override init underscore underscore init underscore underscore self always. And I'm going to take an in file and an out file. And then I'm just going to call up to the superclass and pass myself and let its constructor do its magic. And then do the only thing that I really needed to do with overriding init, which is take in extra information, which was in file and self.outFile equals outFile. Now here's the real magic of our thread. Run. You override the run method. And f equals, we're going to run the zip file. Zip file. This is going to do the magic for us. Basically this thread is going to take a file that we send to it and it's going to zip it up. Self.outFile, where we want for this particular instance to go out to, right, and zip file dot zip underscore deflated. Don't worry too much about this. This is just how you use zip file to zip. And then f dot right, self dot infile, f dot close. So write it, close it, and then print to tell me when you're done. Print finished background zip of so just tell me when you're done printing and done zipping and print it out to the screen. That's our whole class. That's our thread. Now all we have to do is actually run it. So we instantiate this class and call that instance background async zip, and actually if we look, here's some files. We've got those pseudo image files here. So background equals async zip, instantiate our class. Okay, the image, and what do we want to put it in? Archive.zip. Put it in a new zip file. Now that we have this object, which is an async zip, and you see thread 1 initial. So if I could create another thread or another thread or another thread, and I'd have more threads that could run, but it's not actually running. It's not doing anything quite yet. I need to run the start method of it. Now remember, we overrode run, but for whatever reason, the way that you use threading, you could specifically call run, but the right way to do it is to use start, a wrapper. So you basically call that start method. Now, if I hit enter, it would almost instantly return with finished background zip of image 1074.jpg because it's an empty file, so it can zip that really quick. So I'm going to do a semicolon to see what happens if I try and get the main program to print something first. not sure how this will go. Either one, it's sort of a race condition. Either one could finish first. But what I'm trying to illustrate is that the main program can still do stuff. So print the main program continues to run in the foreground. And which one will return first? Perfect. So the main program continues to run in the foreground and then finished the zip of image 1074. Now what you normally do is you wait for the background process to complete. We know it already completed because we saw the print, but we need to tell the program that. So background.join. That'll just sort of wait until that background process completes. And then print. And the reason that you need to do this, imagine if main completes, but there's threads that are still out there that haven't quite come back yet. You really need to wait before you exit out of your main. So that's what this is for, join. A couple other notes about threading. There's a whole lot more to talk about with threading. Perhaps the best way to deal with resource contention, if these threads were writing to the same place, the best way to do it is to have a main thread that takes care of writing to the shared resource and using queue.queue. That's queue.queue.e module to handle feeding jobs into the main thread. I hope you experiment a little bit more with threading and get great at it. That's all for now. This screencast is directly inspired by the official Python tutorial by Guido van Rossum at python.org.